in today's talk, we will talk, as we said, why event sourcing is hard. So just to be sure, I don't want to diss event sourcing. I want just to point out that when you're getting into this, you should be prepared for certain challenges ahead. And if you are prepared, then there's not a big deal. It's just that it's better if you don't come unprepared when getting this stuff. So obligatory, every speaker has to say a little bit about themselves. So I've been breaking things in Scala for the last 5 years. Quite a lot of this time was also related to event sourcing and stuff, which is why I'm able to talk to you today. In general, I was also working in industry for 10 years and programming in general for 18 years or so. In the meantime, I also did a little bit of open source, a little bit of blogging, and also this little niche bug about Scala and JVM. But no, let's get into the details because we have to talk quite a lot about event sourcing instead of me. So first, I want to talk a little bit about what is event sourcing. I don't want to give you like a specific definition because if you have 5 event sourcing experts, you would have 10 opinions what it is, and it's not a religious word that we want to take stand. So we only just want to get the vibe what this is about. Then we will talk a little bit about what kind of pitfalls we might have when we are trying to process those events, which is like the essence of event sourcing. I believe it should also help us understand why it is so crucial that we are like assuming that the events are our source of truth and that we are like believing that they're not lying, which is why it's important that we should take care about creating those events in the first place. That's the reason I put creating events after processing events, so that you would have this intuition why it is important to create them carefully. There are also mentioned other pitfalls. Not getting much into the details because our time is limited, but just so you knew that there's also like more other things to look out for. And then we get to the summary. So first, what is event sourcing? As I said, I don't want to give you like a detailed definition because it's very difficult, very easy to start digging on the details, don't see the first for trees. So instead, I want to take you for a little journey, like from the old school programming with calling things sequentially and then changing them a bit until we get to this event sourcing solution. So let's say we have this really normal code. We have some piece of data, some UI when we're like changing the username. We're pressing some button, filling some form, pressing enter, and some function in our system. We receive this data that this user should have his or her name changed to whatever we pass there, and it should be somehow saved and preserved into the database or whatever we're storing it in. So this is like the simplest version of the code, but it's also like very synchronous, and it also kind of like coupling the action that we are doing in our UI with how it's handled like underneath. So let's try to decouple it a little bit, which is what we used to do with all these GUI applications all those years ago. So someone came to the idea that, okay, we don't want these things to be so coupled. We want to be able to change the implementation, change the UI, and not have this code so intimately coupled together. So we can do this by basically separating the interface which handles the action from the place which triggers the action and passes the information from the UI or client or whatever to the place that the action is actually handled. This is a pattern that was quite popular in a lot of GUI frameworks. So if any one of you ever work with this GUI, you probably seen something like that in your life. But someone also thought, okay, but why should we explicitly register every listener to every action? There's a lot of registration to have these things connected together, wired together. So people started coming with the idea that, okay, we have this one single place where we will push all of those actions, and then we can subscribe in this one single place to whatever actions we want to listen. So then came this idea of publisher and subscriber and message bus or whatever. So This further decoupled this place when we are triggering something from the place when we are handling or reacting to it in whatever way. So, but this system, while giving us a lot of flexibility, still usually is very much coupled in time. Like wherever we are triggering some action, we want to handle it like immediately. We don't care where and who will handle it, but we will still like coupling things in time so that things should happen like as soon as possible. Even if we put this event bus on Kafka, so one microservice will write to it, and I will read from it. Usually we'll still have this time-based coupling, and sometimes it might be an issue. Which is why at some point people came to this conclusion that, okay, instead of actions, which are like current time, like present time, we should handle actions that already happened. Like we got some action, we decided that, okay, we want to handle them. We want to state that something happened in our system, and since it happened, we will refer to it in past tense. We will, because it's in past tense, because it happened, we will basically call this event. We will store it in some journal, which will like be a full history of things that happen in our system. We'll assume that is our source of truth. We will be able to read from this event store or journal or event log, whatever we call it. So a lot of names for it. And then we will try to like basically go through all of these events with some sort of iteration. Here I like use foldLeft to like initialize some initial state. And once we get to the final event, with each event on the way applying some change to the states, we will arrive at our final state. So it's like a very nice way of thinking about our system. Like we're trusting that this journal is not lying. We can like easily derive a lot of computations from it. Like here we can see that we can have a list of users, sorry, a map of users by the ID to their value. And every single time we are modifying some user's name, this user will be, their name will be updated. But if their name, if their user is not there, we will just create some empty user, just for simplicity in this case. And after like going through all of these events, we will receive a map of all the users with their newest names. But because we are like working with this event log, we can be flexible. So we can later on like add some other implementations. For instance, if we decide to compute, okay, how many times someone triggered a username change in our system, we can just initialize with the system with value of 0, go through all the events. When we have the event username change, increase the counter, and otherwise like left it unchanged. In this simple case, we only like dealing with one kind of events, but in your system normally you can do it whatever you want. And we can see that even though we have only like one common history of events, we can interpret them whatever way we want. We can revise it, we can get back to it like several years later on, change the way of interpreting those events, changing way of turning it into some state of computation. As long as we will meticulously write down information inside our events, the information is not lost. So we're not limited with what the current state, with what the current database holds. So what are the issues with this approach? Well, basically, it always takes the whole history and goes through it. So this is not something that you will usually see on production. On production, usually we'll start seeing that, well, first of all, instead of lists, usually we have some sort of streaming because maybe all of these events will not fit into the memory. Also, the result, it would be like easier if we like cache it somewhere instead of like recomputed it always. So we're starting doing some modifications. Like we might want to remember what was the last event we like processed, and if when we start our application, just read the last computed state, last event that we already processed, and like start from that. And once we compute this new state, like persist it somewhere so that we will not have to do all the computation from the scratch every single time we start our applications. Like in many cases, it would be like not applicable at all. But if we like fetch and persist the state in between, This actually unlocks us to actually perform certain things like that. But if we see that we're basically persisting our state and not saving it in between, we can like get rid from this functional foldLeft and instead like turn it into like a for each or into map. So basically, what we will usually see in our system is that we will have some stream of events. We will fetch data in some smaller chunks instead of like big chunk of data, and we will persist only those some smaller chains in our system. So what we are seeing here is something much, much closer to what we will see in our production system after we start working with them. So this is something very, very close to what we will actually see in production systems. And on a first glance, it seems like it should be working like, really well. Like, what could go wrong? Like, this is just a slight modification of this, foldLeft idea, which seems very much bulletproof. So, and this is where usually the presentation about event sourcing ends. So, where are all the challenges? So, first, let's talk about pitfalls of event processing. We won't be able to discuss all of them, but at least we will show some examples that there are things that you should look for. One of the things that you should be aware of is that committing offset upfront might be an issue. Why? So let's take a look at our example. This is the code that we have in the previous section. We are dealing with events. We're getting the last process offsets from the database. We're fetching the events we not yet processed. For each of them, we're applying the changes to the computed state in the database. So, but still we are like managing the offset here manually. So, what if we'll set to the library or whatever? Could you like manage the offset for us? Like, since you are already talking to the database, well, you could just fetch the offset instead of us, and but why should we should bother? And also, once the event is processed, could you also like commit this offset for us, or maybe commit it upfront? Because why we should think about such tiny implementation details. So we will modify our system. Now, when we get new events from the system, we only get those events we haven't yet processed. This function automatically will talk to the database, get the offset, commit the offset after we fetch some event from the database, and we already have to like iterate over it like with normal Java iterator, normal consumer. And we only have to deal with fetching the state from the database, modifying it according to the event, and persisting it. So it's a much simpler code. Like, why we shouldn't do this at all? So, and everywhere. So the problem appears even we start considering like real-life situations like servers crash. It might be like not our fault. It might be some out-of-memory killer. It might be a down edge or outage of the cloud center or whatever. There might be some external issues we can have no control over, even if we are using all sorts of like graceful shutdown and stuff. But usually, at some point, somewhere, somehow, with our ill will, the server will crash or shut down. And what if we were in the middle of processing? Well, if we are like committing, if the offset is committed for us before we even get to the event, server crashes. We started anew. The offset was already committed, so we will not get back to process this event that we were in the middle of processing. So whatever we wanted to do to modify our system, well, this event is already lost. And we would have to manually look into the log, see that it was not processed, change the offset back to the earlier value, and do all sorts of stuff to basically get back to processing in a correct way. Or maybe we shouldn't like restart the application after it crashed, do some investigation, things like that. So it complicates things. That's why it's usually better for us if we just commit the offset ourselves. We don't have to fetch it. It might be useful to either pass it somehow along the way with the event, commit it afterwards, and at least we will get rid of this issue that some events will not be processed in case of an application crash. But if we just leave it this way, we might have another issue. So let's have this example. We have this event processed. We're committing the offset properly, so that to make sure that event will be processed at least once. Well, now we have another issue. Like here we added this send user notification. Maybe it will like change email, post notification to the browser, whatever. It does some side effect with the outside world. So if our application crashed before we committed the offset, sure, after the restart, we will process it again and make sure that the side effects are persisted, but some actions with external system would be called twice. Like if it's just an email, it's not a big deal, not a big issue, but let's say you were just trying to schedule user payment, or if you tried to modify some data or some counters or charge the user or deduce from their quotas, you would do this twice, and it would directly hurt your user, your customer. So it might, reflect badly on the company you're working for. So not in all cases, but in some cases very much. So you should at least think about those cases when you're dealing with these things. That could be like addressed by basically having some sort of event ID. And then when you're processing all of these operations, you could also like use this event ID to see, okay, have I sent notification for this event already? If I did, then, well, I don't have to do this again. Have I modified this data? If I did, okay, I don't have to retrieve myself. So this idea that you can process event twice and make sure that all of the outcome of this event processing is executed, only once, is usually related to this concept which in mathematics we call idempotency, so that you could apply the same function twice to some argument, and after first execution, is the following execution like doesn't change this value anymore. In this case, instead of value, we have the state of the external world, but the intuition still holds. Like we should modify external world like only once when we are processing event to be on the safe side of things. And here is an example. We just added like event ID, and we're just passing it to whatever side effecting function we have. If all we did was just modify database, then there's a simple option. We can just use a transaction, and if the application crashed, the transaction is like rolled back. But you cannot always have this luxury, so then you have to think about things more carefully. Okay, so we made sure that when we have event, it will be processed at least once. And if it's processed more than once, that only one application will have some effect. But that's not the place where our challenges end. So let's say that we have two users, and each of them try to set the same name. In the early state of our application, it's all right, because we're only displaying this username to the user for the pleasure, but it has no deep impact in our system. It's not used for some profile URLs or whatever. We're just hiding it from the user, so we don't have to put any sort of constraints on it. So we are starting an application in version production. We are producing events. They are getting into the log. And then a few months later, the product decides that we start showing these usernames to our users, and they should be unique. So how we could solve this problem that we already have the history when we can have users which have the same name in the new world, when we should resolve the state to something that should make those values distinct. So as far as I can tell, you don't have a single out-of-the-box solution for these kind of situations. Usually you have to somehow plan for them. You have to prefer some sort of either business migration, or maybe you should assume that, okay, some entries in my database will not be unique, some of them will be unique. But then you also know that, okay, I cannot have distinct in this Postgres table when I'm storing those data as a form of view or for better performance when accessing things. Well, because I cannot guarantee these things to be unique. So There's many ways to respond to the situation, but none of them is immediately obvious, something that you will already know how to respond to the moment you see it for the first time, especially on a production when you are unprepared to this kind of situation. Another thing that we might have is working with events in parallel. We decided that this projection is too slow, so what if we have 2 nodes, and each of them process part of the events, so this way we will apply them faster. It's one of the things that people recommend to do, post things in Kafka, and then use some Kafka consumer or whatever, and Kafka just makes sure that all of the events will be processed only in a single place because of its properties and stuff. So there shouldn't be any issues that you as a developer should be worrying about if you're using Kafka or any other kind of this message broker. So let's see some example like this. We have a user. This user has, reserved some name for themselves because we already established that name should be unique. But then his friends came along and he was, I wanted to use this name too, and he was, okay, so I will change my name to something else, and then you can reserve this name that I was using. It should be possible to do. So those people do what they agreed to. One of the users changed the name to something else, and the other user reserved this name. And when we see the history, it's linear, everything's okay. And when you go from every step of the history, at every step of the history, everything is according to the rules. So no issue. But we decided to do things in parallel. So one of those nodes will receive the events as following. Change the name to foo for user 1 and user 2. The other node will receive the information that, okay, change my name to bar. So this is the second change that user 1 tried to do. And what can happen when we have this distributed parallel processing with no, global locking? We can have this kind of situation that user's 1 event, when his name was changed to foo, gets processed a little bit longer because of whatever slowdown the network was having or things like that. In the meantime, even when he changed his name again, got to the second node, but was processed slightly faster because things like that happen when you have distributed system. We have no guarantees how fast and how long things will be processed. So suddenly, events get applied and saved to the state in a reverse order. And we ended up with a situation when this user 1, for a short while, have a name bar, and then have the name foo, even though from our history, as we all saw, it should be the reverse. So now that when user 2 tries to reserve his name, suddenly we have this situation when we have the conflict, even though nowhere in the history this conflict occurred. It only occurred because we tried to do in parallel something which was, projecting the linear history. So some people are addressing the situation in the following way. Okay, when we have a certain entity, in this case user 1, let's always process all events related to that entity in a single node. That is one of the things that people recommending, that when you have Kafka and you're using it as an event path, you set the retention to be infinite so that event will not disappear. So redirect all of the events related to one entity to the same consumer. And this way, you shouldn't have race condition when processing events of the same entity. And I feel that I have to mention this because I was working in at least one company when the CTO and the tech leads were talking about things like, I talked to some consultant and they said, some people are using entities IDs as the partition keys in Kafka. And we talked to consultants and they said that this is wrong because this way processing is slow. Partition keys should always be random and semi-random, so the messages are nicely distributed across all the nodes. So I'm not sure if this consultant actually said it, but I know that the CTO and technical lead understand it like that. So if you have this kind of issue, someone pushes you to this decision, well, suddenly this decision from above might break your system because you introduce race condition that wasn't there before. But what if you do this this way and start to aggregate things based on the user ID or on the entity ID? Then we have like another scenario, like we have a user 1, which also again changed their name twice. User 2 like tries to take over the newly freed name. And now the events are grouped together by the entity ID. So the problem should be solved, right? Well, not exactly, because we might have another situation when the first user reserves their name, but the second event, when they are freeing it, is not yet processed, because we just spread the events to two different nodes and introduce some sort of non-determinants into the system. So now, even though in the history everything was nicely sorted out in a linear way, now that we scattered those events based on the entity ID, suddenly we again have the situation where for a while there will be a clash in the name. This time it's a little bit better than before, because we can assume that, sure, we have clash. We have a situation when two users share the same name, but at least at some point the system will recover. So only for a while this name won't be distinct. Still, you wouldn't be able to use distinct in Postgres table or whatever. But at some point, eventually, the system will resolve the things. It will reconsider and stuff. So on the one hand, the situation is slightly better. At some point, you will get the consistent state of the system, but you will have some intermediate steps some intermediate states where the system is not consistent, according to business rules. So for some people, it's okay. But for some people, it's not okay, so they're forcing the system to always process things in a single projection, in a single node, and never distribute it. And instead of distributing projection to several nodes, if they have more than one projection, then run each projection as a separate node. So I will be able to tell which of the solutions is better for you. It's just something to consider when you are designing your system. So let's say that we processing the events in a correct manner. We came up with some ideas what works, what not. We're still assuming that the history is not lying. So could there be any time situation when our history is actually lying to us? So let's check. Similarly to events, there's this issue of idempotency. So let's say we send a command to the user. We decided to model things in such a way that we are having some sort of piece of data that we will send to our system and order it to change its state and create event. And for the convenience, let's call this piece of data a command. Let's also assume that the command could fail, because it's impossible to have commands that are never failing. So let's also say that we can have either returned an error telling us what went wrong, or an event, or maybe list of events that should be persisted if the operation was successful. So here we have this simple command handler. It gets the command, then it performs some checks, and depending on these checks, it will either create a successful event or return some error. So this is a simplified version. It only checks if user exists, and assumes that if user is not existing, it should return user not exist error. And if the user already exists, it should create an event for it, without validating it further. So one of the things that can happen is something that you usually see when you're using social media or some web shops. Sometimes when you're trying to leave a comment on the site, your browser may stutter, and after it unfreezes, after you press send several times, you see that you posted the comments several times instead of once. For posting comments, it's not a big issue. At worst case, someone will call you an idiot for posting things several times. But if you're having an internet online shop and you press add item, I guess many of you have the situation when the browser stuttered, and when it unfreezes, you found out that you, for instance, added 10 items instead of 1. So if you overlooked it and then press buy, you could be surprised because you're getting billed on that you planned. So that could be some issue for some people. And similarly to event, it could be addressed by basically putting some sort of like request ID or command ID inside this command. So before you are sending command to the server, you're assuming that somewhere on the outside, the client, customer, whatever, in their calls, creates this command ID. And for each another attempt of sending the same command, they will use the same command or request ID or whatever. And this way, you will be able to check, OK, have I processed this command? If so, I can just respond, the same state I responded last time. If I haven't processed it, OK, I can go to all this state mutating logic. Another issue that we can have is relying on the state from the projection. So let's say that this time we will also verify that username is not taken according to the business rules that we should have followed. So how we can change if username is taken? Well, we could consult the database, which stores the information about all of the users and what are the current names and stuff. So what if this database is populated by the projection? So if it's populated by the projection, we can have two users which will try to reserve the same name for a reason. Maybe they have some sort of silly game or whatever. And if those two commands will arrive at the same time, well, in database, there is no information that this username is taken. So both commands will pass. Both commands will result in an event sent to the system. And suddenly, even though we encoded some rule to prevent having two users with the same username used at the same time, we created events which will result in two users having the same username at the same time. So well, basically, we broke our system, or more like we allowed our system to be broken, because the fact that there is this small delay before the projection is processed, and when we give it more event to process, there is this small window when well, the same state is not consistent. Well, that's what the eventual consistency is about, that you have no guarantee that your current state is consistent. It's just it will be consistent after a while. So things like that are usually addressed with, for instance, akka and akka persistence, that you have basically two phases of processing those commands. One of them will hold the state. We will hold some internal state of your entities, which is not relying on the events. And the state is also computed in a sort of a transaction. So when you get the command, you get the current state, you compute a new state or not, and then you're persisting the state and the event. You're doing all of that in a transaction, and the transaction happens inside the command handler, as opposed to the projection. And this way, you are able to eliminate a lot of those issues even before you will create those events. But for that, you should be aware that simply relying on the projection might be wrong. In many cases, projection should be treated more like an optimization or like a source of analysis rather than the source of your current state. Because in cases like that, you might be tripped over the fact that there's always certain delay between the moment you save the event and assume that it's done, and the moment the projection will turn it into some state of your system. And that also means that we should also make those command processing sort of atomic. Let's say we will use database to reserve the usernames for our user and check that this is even allowed. So what if the server crashed in the middle of the operation? If it's not atomic, we could have already reserved the name for our user so that no other user could take it. But we might not emit the event, which will result in this user actually using this name. So if everything was atomic and server crashed, this operation will be rolled back and user could have another attempt at changing their name or whatever. But if you have no atomicity, we can already done some checks and some operation would not perform another, and this could lead to basically a state where, well, on one hand, name is reserved, but on the other, no user is using this name. So this is something that we'll probably have to fix manually by doing calls of database, and That's not what we were promised when we went to this principled functional design of the system. So what other issues we might also have when working with event sourcing? This will be just a list without much digging into examples because we will slowly running out of time, and I just wanted to sketch another issues that you might potentially have. So one of them is that when you have events and you're using event sourcing, then you have to persist them somewhere. And you usually use some format to persist them, but your application lives, it evolves over time. And as you learn or adjust the behavior to new business requirements, your events will change their shape. Sometimes you will have to create a new event because changing the shape of the previous one will be no longer like a possibility. But you have to somehow came up with a strategy of letting yourself evolve the format of your events over time. And there's also a great book by Greg Young which discusses this topic in very, very, very detail. So I just, referring you to this book because the book was named, if I believe, Event Migration or something like that. So just Google it. It's a great book which discusses this topic in very in depth. Another thing is that sometimes you will talk to some external API which don't expose things like request ID, or their idempotency is very limited because they're storing the information about the request only for 24 hours or so. So if you have to retry the request done by the command or whatever after a certain delay, maybe because they have outage, maybe you have outage, who knows, then suddenly you would trigger the same operation twice when you wanted to have it once. So despite your best effort, you will not be able to have this idempotency. So for this case, you also should encode in your system some way to manually fix them by maybe manually emitting some consolidation events or some fix-up events for some situation that might be a necessity coming up basically from the domain that you were dealing with. Sometimes you will simply have bugs. It's impossible to write a perfect application. Sometimes you won't be aware of something, so you will have bugs related to creating events, related to handling events. With handling events, it's a little bit better because you can always fix your projection and run it anew from the beginning of the world. But if you have broken events, then it's a little bit worse than that because you will have to, in worst case, even modify your journal. There's also the thing about GDPR. If you have customers who are European citizens, each of them can ask you, okay, get rid of my data, just because I want so. And he's entitled to do this. So if you're assuming that events are append only, you can never remove them. So how could you at once remove data and have a system which is not prepared to remove the events? So there are many different ways to address this. One of them is about encrypting the personally identifiable data and then forgetting the key. Some other solution is about storing personally identifiable data in a separate event streams, separate for each user, so that if user decides to delete their account, you're removing not the event but just whole stream. There are many different ways to address this, but you should just be aware that this is the issue that you just should think about if you're handling the data of some actual human beings, which might be Europeans. And there might be many other issues that can happen. So it's very difficult to enumerate them all and make sure that I touch all of them. So yes, I won't even try to pretend that this is all the issues that you can potentially have. So getting to the summary, this talk was not about discouraging from using event sourcing at all. It was just so that when you started using them, you would just start asking yourself certain questions like, what would happen if your application crashed, both during event creation or event handling? What would happen if some event or command would be sent twice? I saw it happen before, and you will see happening in your production system, so you should at least think about what the consequences would be. What if you have to rerun your projections? The question is, the outcome would be like deterministic? Like if you remove your database, just kept your events, rerun everything from the scratch, whether you're projecting into Mongo or Postgres or Oracle or Neo4j or whatever you want to target, would the outcome you would get would be the same as the system you just lost? Is your system deterministic? Because quite a lot, this determinism is this value that we have when we're working with events. What if the format of events needed to change? Like you should plan ahead for this sort of things. Basically, is your system deterministic or not? Like if it's kind of deterministic, it should still be good for some cases, but in some cases, if it's like not deterministic and you're like relying on the moment that message arrived, then probably you have something like a event-driven architecture more than event source architecture. So it's worth like at least thinking about what you need and what you have. And also, well, you should ask yourself like why you use event sourcing in the first place, because sometimes you might come to the conclusion that basically you haven't needed it. Someone just convinced you to use it. But if you have a use case for it, if you really see the value for it, then yeah, it's okay. You should also ask yourself, is it helping you achieve your goal? Like, even if you're doing event sourcing in some, like, hacky way, which requires some fix-ups on production, as long as you're solving more problems that you're having with this approach, it might be still, like, acceptable. After all, we are using it for a reason, or at least we should using it for a reason. And what would be the worst outcome? Like, if the worst outcome of some mishandling would be someone losing money, or someone getting the data destroyed or whatever, then it's like something serious. You should think about it carefully. But if the worst things that could happen would be just some page is not refreshed, that some email is delayed or whatever, then probably all of those issues might be less important, and you don't have to like address them in the first place, or maybe don't have to address them right now. That's basically all that I have prepared. So are there any questions?
Thank you very much. Yeah. We have time for maybe 1 or 2 questions. Anyone? All right. Thank you very much, Mateusz, for joining. And we will be now taking half an hour coffee break. Thank you.
Thank you very much.